Welcome to this explainer. I want you to think of your Cambridge computer science exam exactly like a high-stakes space mission. There's absolutely zero margin for error. Think about it. Every single calculation, every logical deduction, and especially every ethical evaluation must be perfectly calibrated for a successful launch. If you're building your foundational knowledge right now in the 0417, 0478, 0983, 0984, or 2210 syllabuses, or if you are gearing up for the absolute ultimate challenge in the 9618 advanced level, you know the pressure is on. But today, we are focusing squarely on a massive roadblock in the 9618 syllabus, specifically Section 7.1, Ethics and Ownership. Let's dive right into this challenge. Picture a dynamic split screen right now, showing two candidates taking the exact same past paper. The clock is ticking down. On the left side, we have Alex. Now, Alex is a genuinely hard worker, but Alex has a critical flaw. Alex overloads every single answer with raw computer science facts, just dumping textbook definitions onto the page, but completely forgets to provide any critical analysis whatsoever. Then on the right side, we have Sam. Sam is incredibly smart, knows the material inside out, but constantly rushes. Sam is always racing against the timer and completely misses the specific requirements of the command words in the question prompt. When we put their flawed answers side by side, it's a disaster. They are just covered in red examiner marks. Their rockets just completely failed to launch. And why did this happen? Because 7.1, Ethics and Ownership, is historically one of the single most misunderstood areas in the entire computer science curriculum. It's notorious. Today, we are going to fix that. We'll analyze the examiner's playbook together so we can secure every single top mark available, maximize your grade, and transform all those red marks into green check marks. And hey, I'm really not just saying that to scare you. This isn't just my opinion. Look at this direct quote pulled straight from the senior examiner's report. They literally wrote, "Examiners report that 7.1 Ethics and Ownership is one of the most misunderstood areas in computer science. Let's fix that right now." Guys, this is the ultimate high-stakes warning. Examiners are explicitly telling us, right to our faces, that students are crashing their grades on this specific topic year after year. And the crazy thing is, it's not because the concepts of software licensing, copyright, or artificial intelligence ethics are impossible to grasp. They aren't. It's because candidates just like Alex and Sam failed to bridge the gap between abstract ethical theory and concrete context-specific application. They treat ethics like they're writing a humanities essay, giving vague, philosophical answers, instead of treating it like the precise, analytical computer science discipline it actually is. They forget they're still sitting in a computing exam.
So here is our mission-critical roadmap for today. First, examiner warnings. Second, core concepts. Third, procedural framework. Fourth, critical analysis. And finally, the method mark strategy.
Let's start with Section 1, Examiner Warnings. We need to look at the absolute most common pitfalls students make.
These are the exact traps that caught Alex and Sam. And these three mistakes perfectly diagnose why students lose marks. Mistake number 1, confusing cause and effect. In ethics and ownership, students so often mix up the root technical cause of an issue with its societal symptom. For instance, stating on your exam that open source software causes data breaches is a massive logical flaw. Open source doesn't cause a breach. Poorly implemented security protocols within a specific application cause the breach. Examiners penalize that lack of precision heavily. Mistake number 2, forgetting to check boundary conditions and edge cases. Now, Sam does this constantly. In a standard algorithmic coding context, an edge case might be what happens when your database suddenly receives a null value or an unexpected string. But in an ethical context, an edge case is asking, what exactly happens when an autonomous vehicle's sensors completely fail in a whiteout snowstorm? You absolutely have to test the limits of the scenario they give you. Mistake number 3, answers are not specific to the context given. This right here is Alex's fatal flaw. Let's say the question is specifically about a busy hospital's patient database. If you write a generic, memorized answer about software copyright without ever once mentioning doctors, patients, medical confidentiality, or life or death data access, you are getting 0 marks for application. Let me repeat that, 0 marks. Relying on generic, memorized answers completely destroys your mark potential. Every single answer you write must be a custom-built solution for the specific mission you've been given on that page.
Moving on to Section 2, let's build that core conceptual understanding.
So how do we actually fix these mistakes? We need to shift our focus from what goes wrong to the fundamental principles Cambridge requires for absolute success in completely unfamiliar contexts. This comparison brilliantly illustrates exactly what examiners actually want to see from you. Look at the average candidate on the left. That's our friend Alex, relying heavily on generic contexts and memorized facts. It's a dead end. Now look at the right. The top-scoring candidate exhibits a connected, conceptual understanding that is completely transferable to unfamiliar contexts. They can drop into any scenario and succeed. How do top students actually achieve this? By using a rigid, structured system. I call it the PEAL framework: point, evidence, explanation, link. Top students don't just dump facts onto the page. They make a clear point. They provide evidence from the source material provided in the prompt. They offer a highly technical explanation, and they link it directly back to the exact context of the question. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, the crucial point here is that the Cambridge syllabus specifically targets these three distinct cognitive domains: knowledge and understanding, application, and analysis. This is where the magic happens. When you just define what proprietary software is on your paper, you are only hitting the knowledge domain. Best case scenario, that is a maximum of maybe 1 or 2 marks. To unlock the rest of the marks, you must hit application. You do this by applying that knowledge directly to the scenario, say a small startup business trying to cut their initial operating costs. Then you must hit analysis. You have to break down the trade-offs, discuss the long-term support risks, and evaluate the ethical implications of vendor lock-in. You have to systematically analyze the problem using evidence-based reasoning. If your answer doesn't touch all 3 of these specific cognitive domains, your rocket is stalling right there on the launch pad.
All right, section 3. We've identified the theory, but now we need the engine. We need the step-by-step execution.
I am going to introduce you to the concrete procedural framework needed to translate your theoretical ethical knowledge into high-scoring technical execution. We are going to rewrite Alex and Sam's flawed answers right now using this exact 5-step life cycle to get their mark potential all the way up to 100%. This is the computer science success blueprint. Step 1. Deconstruct the question. You must decode the command word immediately. Does the examiner say state, describe, or evaluate? Remember earlier? Sam rushed and treated a complex evaluate question like a simple state question. Huge mistake. That caps your grade instantly. Step 2. Extract relevant data. Pull the specific constraints, the user requirements, and the environmental factors right out of the prompt. Step 3. Select your analytical framework. Are you comparing time complexity here? Are you weighing open source versus commercial software licenses? Pick your weapon. Step 4. Execute with clear notation. Plan it out logically. Step 5. Present with correct terminology. This is vital. Instead of writing something vague like, the code is slow, you must say, the algorithm has a high time complexity, which negatively impacts real-time performance. Watch as we apply this blueprint. As we feed Alex's answer through these 5 steps, the red pen marks literally transform into green check marks. By simply following this procedure, Alex has gone from a generic fact dumper to a precise, context-aware analyst. That is the transformation you need.
And this right here is where it all clicks together beautifully. Ethics isn't some separate fluffy subject isolated from your coding. Look at this comparison on the screen. Theoretical principles demand systematic analysis and evidence-based reasoning in ethics. Meanwhile, algorithmic thinking demands step-by-step decomposition, data structure selection, and rigorous testing. Guys, they are the exact same mental muscle. Algorithmic thinking connects directly to ethics because an inefficiently implemented piece of code or a poorly selected data structure can have massive, catastrophic real-world ethical consequences. If an algorithm takes too long to process in a medical life support system because someone chose the wrong sorting method, that is a profound ethical failure caused entirely by a technical flaw. You absolutely must test those abstract ethical principles with the exact same rigor you would use to debug a complex Python script.
Let's move into section 4, critical analysis. This is where we cultivate the evaluative mindset. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's jump right into our interactive workshop phase. This is where examiners really look for candidates who can weigh multiple solutions, rather than just presenting one single narrow view. Look at this matrix. This is your absolute ultimate cheat sheet for decoding command words. Let's do challenge 1 right now, the data scan. Imagine a complex data table on your exam showing performance metrics for 2 completely different cloud servers. You have 60 seconds on the clock. What is the core trend? If the exam command word asks you to compare, you cannot just list the features of server A in one paragraph and then list the features of server B in the next. You will lose marks. The matrix clearly states the requirement. You must identify similarities and differences using comparative connectives. You absolutely must use linking words like whereas, however, and similarly in your sentences. If the command word is analyze, you must acknowledge the trade-offs. Yes, server A processes data much faster, but it significantly compromises user privacy because of its data logging policy. That's the limitation you must explicitly state. And if the word is justify, you better have solid, quantifiable evidence from the text to back up your final recommendation.
Now for Challenge 2, Find the Flaw. I'm going to read you a heavily flawed sample paragraph straight from Sam's mock exam paper. Listen closely and try to spot the error before I reveal it. The company should use custom-built software because it is better. Open-source software is free, but custom software fits their needs. Did you spot the exact sentence losing marks? It's the very first one, because it is better. That is a completely unjustified, weak recommendation. Let's fix it right now using the Deconstruct Solve Evaluate model shown here on the slide. First, we identify the given information, we break it into logical steps, and we solve it systematically. But the vital step, step 4, is to check for reasonableness. Is it reasonable in a Cambridge A-level exam to just say, it is better? Absolutely not. We must execute step 5, make justified recommendations. So let's move to Challenge 3, speed writing. Imagine you have 30 seconds on the clock. How would you rewrite Sam's terrible sentence using the Peel framework we discussed earlier? Think about making a point, providing evidence, giving an explanation, and linking it. A truly top-tier grade A response would sound exactly like this. The company should invest in proprietary, custom-built software. That's your point. The provided case study explicitly notes the company requires specialized, industry-compliant data encryption not found in standard off-the-shelf packages. There's your evidence. By commissioning bespoke software, they ensure complete ownership, source code control, and strict security compliance. That's the technical explanation, thereby directly mitigating the severe ethical and financial risks of a potential customer data breach. And there's your powerful link back to the context. That, my friends, is exactly how you secure top marks.
And remember, evaluating algorithmic quality in this specific module requires absolute pinpoint precision. You cannot just casually say an algorithm is good or bad. You have to specifically identify the time complexity, meaning how long does the execution take as the volume of data scales up massively. You have to measure the space complexity, exactly how much memory overhead does it consume. And most importantly, as we learned from those stark examiner warnings at the start, you must identify the edge cases. Think back to our space mission analogy. If a guidance algorithm uses too much space complexity, the onboard computer runs out of memory and crashes. If you fail to account for a simple edge case, like a sensor passing a negative number for a velocity variable when it shouldn't, the rocket explodes. You must clearly and technically explain the direct effect these complexities have on overall system performance and ultimately user safety. All right, we are entering Section 5. This is the final, most critical phase of our strategy. This is the ultimate rescue mechanism.
I need you to read this text on the screen very carefully. This is a direct, blaring examiner alert. Show you're working. Even if your final answer is wrong, method marks can save you. Listen to me. If you are calculating a complex trace table, or if you are evaluating the logical step-by-step progression of an ethical dilemma, and you make one tiny silly arithmetic or logical error at the very end of a massive question, do you lose all 6 or 8 marks? Not if you showed you're working. Examiners are actually actively looking for reasons to give you points. If your procedural framework is clearly visible on the page, if they can literally see your algorithmic thinking and exactly how you decompose the problem step by step, they will award you method marks for the correct process, even if the final destination was slightly off. This single strategy can literally be the difference between a B and an A star. Never, ever leave your calculations or your logical frameworks hidden inside your head. Put every single step on the paper. So, we have finally established our complete, foolproof computer science answering system. Let's recap the 3 golden rules that guarantee top marks. Number 1. Command word decoding. You have to know exactly what action the examiner is asking for. Number 2. Peel framework application. Point, evidence, explanation, link. Never just dump facts. Number 3. The time management matrix. You must allocate the right amount of time to the higher-order cognitive domains of application and analysis, not just basic knowledge. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with this final, provocative checklist question to ask yourself before every single exam. Are your answers specific to the context given, and do they justify limitations with evidence? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. If you can confidently answer yes to that final question on the screen, you are officially ready to launch.